Hello everyone and welcome back to another video. In this video I'm going to be talking about well, not talking about but more of like implementing a syncly linked list, which consists of nodes where each node stores data, which is integer value, and a reference, which is a pointer to the next node in the list. I'm also going to include methods such as adding elements and printing the linked list. Okay, that's what I'm going to be doing with this video, and it's just a very simple implementation, and I'll explain like throughout the whole process, and I'm going to have everything down into one program. So let's start off with the node class, which is basically like the building blocks of linked lists. So, and since I'm putting everything into one program, I'm gonna write it like this: static class node, and then we're gonna have an integer called data. So int data and node next. Okay, I'm gonna write it down first before explaining. And then inside the node, I want to have the int data, where this data equals data. So, and then this dot next equals null. Okay, so here's the next, and then here's the data. Okay, so I think all right, so let me do this. The purpose of this, it's a represents a single node in the linked list. And so yeah, this basically the purpose. Int data stores the value of the node. Okay, that's basically it says data, and then the node next is the reference to the next node, which is basically the pointer. And then here's the constructor, and then we have here, which is assigns data to the node, and then this one, it's basically set next equal to null, which it's like initially the node doesn't have anything to point on, basically. Okay, so now that this is done, we should go to the next one, which is creating the linked list class. So linked list, and then and we're gonna first create the head, which is node head. And the purpose of this is basically this manages a sequence of node objects. Okay, and then the node head basically keeps track of the first node in the list. Okay, now we're gonna you can just leave it like this, obviously, and that's it. But what I'm gonna do is I'm gonna put in the methods such as the adding elements, or basically adding nodes, and printing. So right here, just give some space, public void add int data. Oh, sorry, not that again. I'm gonna there we go. So we're gonna have this, and put node new, and then we're gonna call it new node equals node data, and then if head right here, if head is equal to null, then head equals new node, and then you return basically nothing, but if not, we're gonna write this node temp equals head. So while temp dot next is not equal to null, temp equals temp dot next. temp is just as like temporarily, you know, it's just a short way to say temporarily equals new node. Now here now that I wrote it, I'm gonna explain it. So the purpose of this one is this adds a new node at the end of the linked list. Okay, so for example, we have the head. Let's see. No, right. So we have the head, and if I want to add something, then let's say if I want to add a 3, it'll just look like this, and if I want to add a 4, it'll look like this. You know, it'll just keep adding. And I'll try to explain it. So I'll explain the steps basically. So first we create a new node with the given data. Which is this right here. And we will create an if statement. So if no is empty, it means the list is empty. And then we'll just set the head as the new node, meaning there's no value in there. It's just a head. And then you return it. And if head is not equal to null, then we'll continue, right? So otherwise, we'll traverse the list until the last node. So this right here. Oh, yeah. So so what's gonna happen is let me explain this part first. So we're gonna create another one called temporarily, and that's gonna be equal to head, right? And what's gonna happen is think of this. You have let me make it into a comment actually. You have a head, and this head is pointing at a certain value or no value right now. But what we're gonna make is we're gonna create a temporarily that's gonna equal to head. So it's not pointing, but it's equal. So temp and head are basically the same thing now. And so if you think of these two as being the same thing, and let's say that there is a value in the front like this, meaning that temp or head dot next is not equal to null, which it isn't because it has a value in the front, then temp equals temp dot next. So since it's true, this temp no longer becomes the head, but temp becomes the 3. And then you keep doing that until it becomes false. So temp equals 4, and then now temp dot next, which is the next one, it is null this time because there's no value in the front, right? Then that means temp dot next is the new node. Okay. And so yeah, once we reach the last node, we will set the temp dot next equals new node, linking the new node at the end. And so we have, with time complexity on this, it's in the best, there's best case and worst case, right? So best case would be the list is empty. List is empty, meaning there's nothing, right? All you have is just the head. You just have the head, and that's O of 1. And then worst case would be you going, let me put it on comment again. Worst case is when you have to go down the list, basically, right? And that would be O of N. Basically, traverse the entire list, all of them, all the way to the end. All right, now that we've created adding new node at the end of the linked list, we'll now create the other method, which is to print the linked list, right? And this one's fairly easy as well. So public void print list. There we go. And then we're gonna have node temp temporarily equals head. You know, again, it's kind of the same thing. Yeah. So while the temporarily is not equal to null, then we'll print out the data, temp data, and then an arrow sign just to indicate that this is going, I'll explain it afterward. Temp equals temp.next. Oops. There we go. What am I doing? I'm supposed to be putting this inside. There we go, much better. And then lastly, we'll just print out. No. Now I'll explain. So the purpose of this is it prints the entire linked list. Okay. And the steps are, so the first step is, you start from the head and traverse the list. Okay. And each time it'll print out each node's like data, basically. So right here. So since, again, if we use this as an example, let me just remove this and put this here actually. Head 3, 4, 5, and then null. So we're gonna have the temp equal to head. Temp is not equal to null. You print out the data. So it's gonna print print out head, and then it's gonna move to the next one, temp.next. So temp will become 3, still not equal to null. It'll print out 3, go to the next one, 4, 5, and then once it hits null, it prints out null at the very end. Okay, so it stops when we reach when temp temporarily equals null, and it will just print out null. Now with the print list, the time complexity is just O of n, because you're going through the whole list, the whole element. But you're only doing it one, so it's O of n. Now let's go to the main page and we should run the program. So linked list, equals, give it a name, we'll just call it list, and then new linked list. Boop, there we go. And then, so we're gonna use the method, this over here, add. So list.add, let's give like, I don't know, a 10, list.add 20, and list.add 30. Oh, so look, it even says data right there, cool. And then list print all. Well, not print all, print list, because of this right here. If we run this, it should print out what I wanted to print out. Yep, there we go. So print out 10, 20, 30, and then null. So you run the program, it creates a linked list object named list, and then I basically add the 3 numbers, which is 10, 20, 30 to the list, and I call it out to display it. So let's see if I can, is there anything else I can explain right now? Actually, this should be pretty simple for now, yeah. And I think with the next video, I'll try to explain or basically explore other parts of the linked list, such as like deleting a node, searching for an element in the list, reversing it, and after all of that, then I'll explain how a doubly linked list, how it works with like nodes that have like a previous and a next pointer. All right, so thank you guys for watching. Peace. See ya.